Hi, so what I want to do is I want to go over the questions in the assignment that relate to analog to digital conversion. And we'll look at some of them at the moment. And then as I go through the theory notes, hopefully these will help you make sure that you're able to do these questions and understand what's going on behind them. I need you to also look at the questions on the analog to digital conversion, which are in the practorials. Really important that you do those so that you get a good firm understanding of what's going on. So let's just have a look at this question 43. You may think, many of you may think that this is fairly straightforward. However, I know that there's a good number in the course who are doing software and really didn't perhaps click with some of the stuff around analog to digital conversion and electrical that we did last year in 101. So I just want to go over this and really the fundamental idea about converting from the analog world to the digital world requires changing some sort of external world phenomena into a change in voltage, and really pretty much we use the voltage divider for this. That's why it's so important. So that's the reason this question is in there. Let's go on to the next question. Okay, so in question, oh, hold on, I didn't click on that. Oh, there we go. There it is. On question 44, again, this whole idea about understanding the voltage divider simply as a ratio type thing. It's really important to get this idea and then be able to look at this and think, well, actually, which one of these is going to give me a better ratio? And that's just how I want you to look at this. Just look at this and think about the ratios. And really, because it's not about the values as much as it is about the ratios. Cheers. Yeah. And the next question here, what we're starting to look at now is actually analog to digital conversion. So again, there's the voltage divider. We've stuck it into just a 4-bit ADC. So we're comparing to 5 volts, and then I just want you to think about, for instance, what the value of the ADC will be showing at this particular time. Should be able to work this out mathematically without too much difficulty. In this question, we're starting to engage with something. Actually, let's connect this analog to digital thing to the real world. And what I've done is I've connected it to a potentiometer, which is a variable resistor. And the resistance of this varies from, well, typically around about sort of 270, 290 degrees, something like that. And the value at, for instance, 0 will be 0 on an ADC output. And for instance, when we've got the potentiometer turned all the way around to the end, it will be 1, 1, 1, 1. So now you've just got to do a bit of math and figure out what these values will be. And this is really important in getting this understanding about how the analog to digital converter works. So you can do this by changing this here on the slider, and you can see that what you're getting out. Okay, and you can also begin to engage with this idea of quantization at this time, because a change in voltage will have no change in output of the ADC. So you can see there's a small range there that won't actually change the ADC output. And this is quite a good way of picturing for you quantization. So let's go on to the next question. Now this one here is a little bit more tricky, and a lot of people have trouble with this. So I'm just going to give you a bit of thoughts around it. This is really your understanding of electric potential here. The fact that we've got a voltage which will go from 0 to, well, let's have a look at it. We've got -5 volts here, but the ADC won't actually kick in until it gets to just over 0 volts, okay? So what we're doing here is you've got to think about, well, what values was the resistor going to be to give me a 0, and what value is the resistor going to be to give me, say, 1.1 volts? And so I'm thinking that we've got a range here of 0 to 1.1 volts, but this is swinging from -5 to +5. So we're only looking at a small part of this range is what you've got to think about. So only a small part of this potentiometer will actually be giving us an output which we can read on the ADC. Below a certain point, it will all be zeros, and above a certain point, it will all be ones out. And you've got to work out what those 2 points are. But of course, you can do that because this is really simple, just algebra. Once you get to see that the problem is just algebra, you'll be fine. In the next question, we're again engaging with analog to digital conversion at a deeper and really interesting level, because here we're looking at something that is the real world, which is temperature. And the device we use for sensing temperature is a thermistor, and it's a non-linear device. So you'll be able to see here, for instance, that when you read this off the graph, what value are you going to get out of your ADC? That's what this is all about. So just understanding your graph reading skills is really that. Once you've got the answer right, it'll close this and you'll be able to see what things are doing here. Okay, so yeah, I think you'll be able to handle this question all right. It does often raise a few questions from students, but actually just take your time through it and you'll see that it's fine. And now what you've got to do is you've got to add an LM35 to this. And LM35 is a nice little temperature sensor device. And what you do is go to devices and we'll look for the LM35, and then you've got to follow the instructions. In this particular case, I've got to connect it to C1. You will have to connect it to whatever the option is. And when you click on this, you'll see that we get a little slider here. And this slider here goes from 0 volts here all the way through to 1.5 volts here. Okay, so what we're getting there is this is actually a linear temperature device. It has a nice linear range. Inside it, there's quite a bit of smart stuff, and basically the thermistor is linearized over the range that we're interested in. And then you've got to start thinking about, well, actually, when this is at a certain value, I want in this case here, I want my fan to come on. So you've got to add a fan. So, really adding something like that is just a generic output. Okay, there we go. And I've got a particular pin I've got to add it to, I think B3 in this situation. Okay, and this has got to be labeled, it's got to be labeled fan. So not hard to do this question. And what else is required in this question? And you've just got to figure out when to turn the fan on and off, and it goes on and off between a certain set range of values. So it's not really too different from the potentiometer type question, and understanding that we're only interested in a small range here, and you're given this range in the question. So the fan has got to go above, it's got to go on above, in my case, 84 degrees, and it's got to switch off below 40 degrees. So yeah, I think you just think about this, you'll be fine. Most people get through this without too much difficulty. The next question, here's an interesting little one I've put in here. Look, you'll see this little thing won't disappear. It's from the previous question, so just close that. So what you've got is a keypad here. I've shown a keypad here which has got 12 buttons, and it's in a voltage divider. So actually the voltage at this point here will vary depending on what the path through the voltage divider is. So you can see that this 680 ohm here and these resistors here all make a form of a chain. But when I close a switch, what it does is it shorts out a particular resistor or group of resistors, and what you get then is a different voltage divider here. And of course, that helps us then. We can stick it into an ADC and we can do some readings. So in this case, what will be the output voltage when switch 2 is pressed? So switch 2 is here. You can see which resistors are in the voltage divider and which ones are shorted out. So it's again it's getting back to that understanding of voltage dividers, what's happening with current and voltage, electric potential in the circuit, and what a short circuit means. Okay, and here you can take that to your advantage here and use it. Okay. So where are we on? Question 50. So we've got one more, I think. Question 51. Okay, so here we've actually got a keypad again. This is interesting. So what happens is here, when you click on a particular digit in the keypad, what you get is a different value, okay? And so this is based upon the previous question, understanding how a keypad could be used in a voltage divider. Now, it's not too common to use a keypad in this way, but it is quite useful for people who've got a microcontroller, which has only got a certain number of buttons. And so it's quite good. And in this case, what you have to do is you have to figure out how to turn on a particular LED when you get a value. So this, you've got to write out quite a bit of code here, but it won't take you too long once you get into the swing of it and understanding it. So I just wanted to put these up in front of you before we go on to the next part of the course. You want to engage with these and get into them as soon as you can. Just encourage you to do that. Okay, cheers.